So instead of just using block matching on this block, I can actually use the motion vector that's next to it. So I can use the motion vector next to it to help me decide what the best block is. So what that means is that as I'm over here and I'm doing some search around to find the block, I choose the block that's going to give me a motion vector that when I subtract that motion vector from this guy, it's also going to be minimized. So that essentially says that for this block here, it's going to try to force me to have a motion vector that looks something like this, right? Because the error between those would be 0. So it's recursive search because it's using the previous motion vector to find the next one. So for this one, this is really fast, super fast actually. This way you don't have to apply the energy minimization at the end, right? So this is the way to apply it recursively. Still, the motion vector quality is not as good as if you had done it, wait until the end to do it, right? But this is super famous. If you like Google this guy's paper, I'm sure he has a few thousand citations. This method has been used a lot.
And is it comparing quality and comparing a big space with many small objects, like a star field, versus a thing with big objects and little background?
Yeah. You mean in terms of just
The
making it more
quality.
difficult to choose
The quality
of the motion vectors?
yeah.
It actually does pretty well, and the reason that it does really well is because after it does this once, it goes back through it. So it does multiple iterations of this. In any of these algorithms, actually, you want to do more than one iteration, because when you correct motion vectors on one row, when you go through the next row, you're changing those motion vectors, right? Because remember, we have this 9x9 window of motion vectors. So it means that when we go back through another iteration, we can possibly change motion vectors that were not there in the previous one. Does that make sense? You guys? Yeah. So when you go back through more iterations, I'm going to be changing the motion vectors again. And if you do this about 3 or 4 times, they generally start to get fixed, or they're not going to change anymore. So 3 to 4 iterations is probably the max you need to do to get them fixed. Yeah, so that kind of sums up the block matching approach.